Hello, good morning, good afternoon, and good evening, whenever and wherever you're watching this video from. Welcome to my YouTube channel. In this video, we're going to answer this question. This is under vectors. This is an examination question, okay? Vector geometry. So now, without wasting much of the time, let's jump right in and solve this question together, okay? So the question says, in the diagram below, AE, vector AE is P here, AE is P, AD is vector what? Q, and this another information is AE is equals to what? Is equals to EB. Vector AE is equals to vector EB. Okay. AD is equals to DC. Okay. Where is that? AD is equals to what? Is equals to DC. Okay. Then they are told that DE is parallel to CB. DE, where's D? DE is parallel to CB. Yeah, yes, we can even see. That's the usage of the meaning of these symbols. Okay. Then also given the ratio CF, where is C? CF here, CF to FB is 1, 2, 3. So here there is 1, here is what? 3. Now, let me just explain this to you so that you understand. Let me just indicate here that here is 1, here is what? Is 3. Okay? Is 3. So the total distance from C to B is 4. When you add 1 plus 3, it's 4. It's divided into 4 segments, not just the distance, but segments, 4 segments. So I'm going to show you how to use those ratios. Okay? So let's solve the question. So it's saying express in terms of P, vector P or slash and slash or vector Q, DE. The first question is always the simplest. The first question is always the simplest question and is the easiest to solve here. So we are going to find the D what? DE. Okay? So DE here. So this is what we're going to say. Okay, let me use this party for solution. Okay, for the first one, which is DE, the first thing, since we're starting from D, then D is the origin. So we're going to move DA plus AE. Okay? So DA, vector DA plus vector AE. Okay? That's the matter of substituting there. We're calculating DE. So DE is equals to, what is DA? What is DA? Check. AD, so this one, this vector is just coming down here. It's like this. Like this. AD is positive vector Q, meaning the opposite is negative. DA moving in the opposite direction is what? So it will be negative vector Q. Okay? Plus what? Plus, check AE. And AE, AE is vector what? Is vector P. That's what I told here. That AE is vector P. So I'm going to write the way it is as vector what? Vector P. Are we together? Vector P. Now, this is negative and this is positive. So we always start with the positive what? The positive vector. So we're going to start with the vector P minus vector Q. Okay? This is the what? This is the answer. The first question. Okay? This is the DE. Okay. DE. Are we together? Question B. B, we are told to find vector AEC. So B here is EC. C. Don't forget origin. The first letter here, the first point is the origin. Where is E? Okay, E is here. So I have to find E what? E, C. Now, the question that I may pose and to you, my good friends, is that how are we going to move? How are we going to do what? How are we going to move? Now, there are a lot of ways. You can either go C, it's what? It's EC. You can either go EB plus BC or EA plus AC. Okay. Now, which way? Always choose the shorter what? Shorter length. Okay? Shorter what? Length or side. Okay? So, shorter length or side, what does it, what do I mean? I mean the simpler what? Way. Okay? So we're going to use this side. Why? Because we know this vector and this vector. Okay? We know AD. We're told here that AD is equals to DC. So there is vector Q. Even here there is vector Q. Are we together? Good. So this is what we're going to do. I'm going to say EC is equals to EA plus AD plus DC plus DC. Okay? Now, here is the issue. What is EA? EA is opposite of P. So it will be negative. There's a different color here. It will be negative what? Negative vector P plus AD. AD is the direction of the what? Of the vector. So it will be Q plus, we are taught here that AD is equals to DC. So if AD is Q, even here is Q. So even here there is Q. So even here is what? Is Q. So it's Q plus Q. Okay? So even here is what? Q. We can just simplify there. So we have P there. Q plus Q, it is 2 what? 2Q. And always start with a negative, positive vector. So we're going to write 2Q minus vector P. Okay, don't forget to write vectors. Okay, so this is the solution. This is the answer. This is the answer to the second what? The second question. I hope you are following. If you are together up to this point, please consider subscribing, like the video, also share with your friends, okay, who may also benefit from this. All right, vectors are very simple. Okay, vectors are very simple. You just need a little bit of understanding also the basics, how it's done. Need to know how to interpret this, the ratios here, and also when you're told this is the midpoint of what, something like that. Those are the few things that you need to know when it comes to vectors. Otherwise, don't be on pressure. Vectors are very simple. Okay, let's try by all means, you know them. All right. C, I'll solve question C from here. C, we're told to solve vector C. COO is CB or CD. Okay, CB. Where is C? Ah, C is here and B is there. You see the reason why we did not use this route, because BC, we don't know what BC is. And this is where now we need to calculate C, the opposite is CB, not BC. Okay? Now, it is very simple. It is very simple. So, CB is simple. Why? Because it is just the origin is what? The origin is C. The origin is what? C. Correct. So, since this is the origin, we are going to move C A plus AB, or AE plus EB. Get it? Correct. Why? Because we know this distance, and we know the vectors here, and we also know this vector, and we are given this information that AE is equal to EB. So if here is P, which means that even here is vector P. You see how simple this is? Good. Simple. 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 Okay, so we're going to move CA plus AB. Okay, AB. Now, you can also use CD plus D, A plus A, E plus E, B. Okay, but you just waste your time because you know these vectors. Okay, so just write quickly what is it? CA. What is CA? AC is 2 vector what? 2 vector, we used AC somewhere, which is from A to C here. It is 2 vector Q. So opposite is negative 2 vector Q. Okay? This is 2 when coming down, 2Q. So opposite is negative 2 what? Negative 2Q. Plus, this is P. This is P and that one, and not Q. Okay? So, always start with a positive vector. So we're going to write 2 vector P minus 2 vector Q. So here we can factorize. Common factor is 2. 2 there. So here just remain with the vector P minus vector Q as the answer. Because 2 into 2 is just the 1, and 1 is invisible, just remain with P. 2 into 2, and so remain with what? Remaining with the Q. Now, my good friends, I want you to understand one thing when it comes to vectors. If you've noticed, if the first answer is wrong, usually the second will also be wrong, and the third will also be wrong, because they are interdependent. The answer for the first question may be used in the second question. The answer for the second question may be used in the third question. Something like that. Okay? Now, this is the most interesting part, where you need to show, where we need to show what? This, we are given the answer, and we are asked to show if it truly is correct. If that one is what? Is correct. So what do we do? What do we do in this case? It is simple. As long as these are correct. If these are not correct, this will not be what? Will not be the same. Okay? Not be the same. So, excuse me. What am I going to do? Let's do this. Let me just create space. Let me just write these answers here in case we're going to use them. DE, the answer for DE is P minus Q. Then the answer for EC, EC is 2 vector Q minus P. Okay, so I can just create this. I'm going to just erase this space. Okay, this, okay, just erase this work here. Okay, the last one, we asked to show that this is equals to this. Now, where do you start from? Where do you start from? You always start from whatever you are given here. So we're going to start with EF. So that will be the first point. So this is question, okay, Roman numeral 2. So we're going to start with EF. So EF. We need to find this. Now, how are we going to do? So in the meantime, let's forget about this. Let's concentrate here. EF. E is here and F is here. Simple. It is simple. We're going to move EB plus BF. Find EF. We're going to move EB plus BF. Now someone may ask, what if you go what's this? DC plus CF. You still find the same answer. Remember, always use the easiest way. Or you can also move ADDCTF. Same, we find the same answer, but now here just the EBBF. That's it. Okay. Now, so EF, let's substitute. EF is equals to what is EB? EB is vector P. Vector P plus what is BF? BF. Ah, great. Check. CB is, where's CB? CB is this one. This is CB. So we're going to use the expanded D one, which is this one. So meaning opposite, it is negative. Are we together? Great. It will be negative. So it will be negative. All right. So we are going to say, I'm going to write, what is this? Let me not even put a plus. Okay. We're going to say negative from here up to here is 3. 3 over, I want you to understand here, 3 over what? Total segments, 1 plus 3, 4. So 3 over 4 of CB, of CB. Now I need to substitute CB there. Okay, so let me just say is equals to P minus 3 over 4. The negative is coming from, it is opposite of CB. We're going in the opposite direction. The 3 is this one. The 4 is the total segment 1 plus 3, which is 4. Okay, open bracket. What is CB? CB, just get the factorize the answer, get the expanded one. So I'm going to say, we're going to get 2 vector P minus 2 vector Q. Okay, like that. Then we're going to expand. We're going to expand here. So we're going to maintain P here. P. So we're going to say vector P negative times there is an invisible positive there. It will be just positive. Okay. Now here you can just do the calculations. Division. 2 into 2, 1. 2 into 4, 2. So it's the same as we have 3 over 2P, vector P. Okay? Then negative plus negative is positive. Okay? So you also do the same. You do the same. The 2 there, 1, 2 here, 2. So just remain with 3 over 2 vector Q. Now my question still stands. Do we have common factor? Yes, we have. There is P here and here there is what? There is P. Therefore, we're going to say here we can solve here. So we just create space. Just create space here. So common factor, so over 1, common factor here is what? 2. 2 into 1. Let me write nicely. 1 into 2, not 2 into 1, sorry. 1 into 2 is 2. 2 times p, it is 2 vector p minus 2 into 2, 1. 1 times 3, 3 vector p plus 3 over 2 vector q. There. Okay. So we can solve here on top. 2 minus 3 is negative 1. And d, so you just write negative what? So this is like negative p. Okay. Over 2 plus 3 over 2 vector q. Okay. Vector q. Okay. Or this one can just come on top here. You just write 3 vector q over 2. Okay. Now, when you reach this stage, that's when you can factorize. You can factorize. By the way, you can first arrange, start with a positive one. So you can just write 3 over 2, 3q over 2 minus p over 2. So here, on top here, we have 3 and 1. So the common factor is what? Let me even use a different color here. We are almost done. Okay. So here, the common factor here is what? Is 1 on top here. Common factor is 1. Then down here, common factor is what? 2. So we have 2. 1 over 2. Expanded. Okay. I mean factorized. So open bracket. Then 1 into 3. It is what? 3 times 2 and 2 will cancel. Are we together? 2 and 2 will do what? Will cancel. So let's remain with what? Q minus, okay, minus half into half. Half into half is just half. There is an invisible 1 here. So 1 over 2 will cancel. Just remain with what? Just remain with the p, which is vector p. Okay, let's compare this one with the here. 1 over 2, 3q minus, yes, this is correct. All right. So hence shown. Simple. Okay, you see, it's simple. Now, if you've enjoyed the way I've explained and the way I've solved this question, why can't you just give us a like, a comment, and also share with your friends? This is the only way you can help the channel grow and also being able to be recommended to other viewers as well. Thank you so much. See you in the next video.